Alright, in the last video I talked about the basics of circle milling, and we called the X0, Y0 the center of the hole. We used a 2-inch diameter hole, 1/2 inch end mill, and it's really easy to come up with your absolute X and Y values when the center of the hole is X0, Y0. So this is basically what the code looked like on our initial move. Before we arc into the circle, we activate our cutter comp, we come all the way around, then we arc back out at the top of the circle, and then on our last move we cancel cutter comp. Now those were really easy numbers to calculate because X0, Y0 is in the center of the hole, but as soon as you have a hole that is away from the origin, let's say you have multiple holes in your part, you would have to recalculate every X and Y location, even though the hole size is the exact same. Okay, and then if you have multiple holes in your part all the same size, you would have to rewrite the code for every circle. So that is if you write your code in absolute values. So we're going to talk about simplifying this by writing incremental values for the X and Y coordinates. So let's take a look and see how that works. Alright, so we're going to start at the top of the program. We got our program number. We're going to use tool number 1, which is a 1/2 inch end mill. We got our safety line. And the first hole that I'm going to show you is going to be using absolute values, just like we saw in the previous video. We call up our tool, turn on the spindle, and we wrap it to G90, G0, G54, X0, Y0. So we wrap it to that location. We call up the tool offset. We wrap it to 0.1 above the part. Then we feed inside the hole to a depth of Z minus 0.5. Okay? Then the first move we make is G1, G41, D1. So that activates cutter comp. And we stop at Y 0.5 right before we arc in to our circle, and notice each value is at a distance away from the XY origin, which is in the center of the circle. So notice the Y value on the next line is going to be larger, okay, the Y 0.750 at the time that we engage with our circle. Then from there it's a J minus 0.75 to complete the circle all the way around. The G3 is modals, therefore it knows to do a complete circle, come back to that same point, and then we arc out on the next move, and notice our Y value becomes smaller again, and then even smaller once we move back to Y0, where we cancel cutter comp on our linear move. So now I'm going to use incremental code, doing the same exact circle. So now notice the difference in the values in incremental mode. So first of all, I'm going to move up to Z1 inch, wrap it back down to Z 0.1, and this time I'm going to feed to Z minus 0.4. So now, where do I activate incremental mode? Well, it's on the very first line. Once you're down inside the hole, you need to stay in absolute mode all the way until you're at the right depth, okay? Because the depth needs to be an absolute value or distance from the top of the part. Okay, so only once you're inside the hole do you actually switch to incremental mode. So the first move we make is still a linear move. On that line we turn on our cutter compensation, and the total distance traveled to the lead-in move is still Y 0.5. But now every move thereafter you're going to calculate the actual distance traveled for each move. So we're going to do a G3 next, and that is the lead-in move. Now notice on the previous segment that was a Y 750, because that is the absolute value away from the center of the hole. In this case, since we're doing an incremental move, the total distance in Y moved from our Y 0.5 is 250 thousandths. Now we did an arc, and we did that using a G3 counterclockwise arc, and the distance from that start point to the center point of that arc is still a 0.125 distance. Okay, so that stayed the same. Now to go all the way around, we have to tell the machine where is the center point of the radius that we're going to be swinging. So the distance from the point that we are at now to the center point of the radius is still minus 0.750. So that is the same. Okay? It is not until we complete that move that we're making a incremental distance move, which is a total distance of y minus 0.250, because I moved in the minus direction, a total distance of 250, and the center point of the radius that I was swinging is from the start point 125 thousandths to that center point. I hope that makes sense. Then we have one move left, and that's going back to center. So that is a ½ inch distance. So we're going to move not to y0, but a total distance of a ½ inch back to the center of that circle. And on that linear move, we're canceling cutter comp. So that is how incremental values get you the same toolpath. Now, if I look at it at a 3D perspective, you can see I used minus 0.5 on the first absolute move and then minus 0.4. So you can see that those toolpaths are laying right on top of each other. See that? So you get the exact same results. One is using absolute values and the other increment values. Now let's go on and let's go to the hole that is at 8 inches in X and minus 3 inches in Y away from this hole. Now before we move on to another hole, obviously we have to come out of this hole. We are still sitting at Z minus 0.4. So to wrap it to a clearance plane of Z 1 inches, first of all we're going to have to change back to absolute mode. So on the next line, G90, G0, Z 1 inch, we wrap it out of the hole, having traveled a total distance of 1 inch 400 because we were minus 400 thousandths, and we wrap it out to a clearance plane of Z 1 inch because we are in absolute mode again. So once we are in absolute mode, we wrap it to the next hole location, which is at X 8 inches, Y minus 0.3. So we're going to complete that move. I'm going to zoom out so we can see that. So you can see that's the hole away from the other. And now we're going to use the exact same incremental code to machine this circle. So we are now on location, X8, Y minus 3. We stay in absolute mode until we are completely inside of the hole. Okay? So wrap it to Z.1. Now we're going to feed to Z minus 0.5. Now once inside the hole, that first move we make is an incremental move from the center to our lead-in move. Okay, and now it's the exact same code that we used in the previous segment to produce this hole. Once I complete that, I have to wrap it out of the hole. I want to wrap it back to a clearance plane, but that needs to be a G90 move. So right there on that line where it says G0, Z 1 inch, I will have to put a G90 on that line. So let me make an edit here. So when we wrap it out of the hole, we want to do that as an absolute move. Okay, so now let's say that we need to do a hole at a different location. Now I'm going to copy this whole section of code right here. I'm going to do a Control C, put my cursor when I want to paste it, and do a Control V. Okay, so now I want to do the next hole at X 8 inches, but Y 3 inches will be the center point of that new location. Okay, so if I zoom out, having copied that exact same code, the only thing that's different is the location of the hole in absolute values. Okay, so if I copy that again down below here, Control V, and now I want to go to a hole location that is on the other side of the part, X minus 8, let's say Y 3 inches. Notice I can keep producing the same diameter hole just by changing the X, Y locations of the absolute distance away from part 0. Okay, so I'm going to do that one more time. Control V, and now I'm going to make it X minus Y minus 0.3. So now I have the 5 holes using the exact same incremental code to actually mill the radius, but I did not have to rewrite the code for the actual tool paths once I'm inside the hole. So that really simplifies your code and speeds up the process of writing your tool paths. So I hope that makes sense. Thanks for watching, and we'll see you in the next video.